we're basically doing now is we've done everything. We've done our translations, okay? We've done our reflections, we've done our stretches, and now we're talking about the combination of them. Okay, so we've done everything. Now we're talking about combining them. And then we're going to see when does order matter and when does order not matter. Okay, that's what we're going to investigate today and do a couple combination movements, okay? One thing, too, I think just maybe something to assume that you may forget or not quite know. Transformation is all of those things I said. Translation is the plus or minus. Okay, when you're translating something, you're moving it plus or minus. Transformations, how are you moving the whole thing? Whether it's stretched, reflected, all that stuff, okay? So let's look here. Previous lesson, this is just talking about how we know what vertical and horizontal translations are. We know what reflections are. We know what stretches are. Okay, so let's look at the first investigation. So sketch the image of the function after a horizontal stretch by a factor of 3, followed by a vertical stretch by a factor of 2. Okay, they want you to do that specific order, and then we're going to flip the order and see if our pictures are the same. Does that make sense? We're going to do a horizontal stretch by a factor of 3, then a vertical stretch by a factor of 2, and then flip that order and just see if the pictures match up or not. Okay, so let's go and do that. So horizontal stretch by a factor of 3. So this is at 2, so where would it be now? 6, right? Good. Don't all say it at once. Just calm down. So it'd be 6 and negative 6 times by 3. Okay? Because this is the factor. I don't have to do 1/3. I'm not writing the equation. It's telling me what the factor is, so I'm doing it. Okay? And then a vertical stretch by a factor of 2. So this would be at 4. And so this is what it looks like now. That's what it was transformed to. Okay? So we're going to do it again, but we're going to flip it. I'm going to do the vertical stretch first. So vertical stretch 2. Horizontal stretch. And you can see ends up being the same exact thing. So you would say no difference or no change. Okay? So it didn't matter the order there. Okay, so that was a horizontal and vertical stretch combination. No problem with those. Okay, so let's try vertical translation and a horizontal stretch. Sketch the image of a function after vertical translation 3 units up. So let's move this up 3 units. So that's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. So I moved it up 3 units, followed by a horizontal stretch of 2. So this is at -2, so it's going to be at -4. Positive 2 is going to be at +4. That stays the same because it's on the 0. So that's what your graph looks like. It's like a sad face. So I moved it up 3. I stretched it out 2. Should be 4. I'm at 5. Oh, I'm at 5. That's why it's a little bit off. Thanks. Yeah. Good catch, Maddie. Yeah, sorry. A little bit off. That's right there. Boom. There we go. Now she's good. Good. Thank you. Okay. Sketch the image of the function after horizontal stretch by a factor of 2. So now we're going to stretch it first. So I'll make sure to do it 4 and 4. So it's stretched there. Remember, when you stretch, the y-intercept stays the same, so it's right there. And now we're going to move it 3 units up. So these 3 dots, I'm going to move up 3. Is it the same thing? Yep, no change. So that was okay. We good? Okay. Let's check out combining vertical translation and a vertical stretch. Vertical translation and vertical stretch. Okay, so sketch the image of function after vertical translation 2 units down. So I'm going 2 units down, so it's there, it's there, it's there. So I was kind of taking those main points, the y and the x-intercepts. Followed by a vertical stretch by a factor of 3 about the x-axis. So a factor of 3, I'm not reflecting, I'm just stretching, right? Because it's not negative. So that's times what? times 0, right? It's not going to go anywhere, so it stays there. These grow from 2 to 6. Just like that. So it looks like this now. Now let's look and see what happens if we do it the other way. Vertical stretch by a factor of 3, followed by a vertical translation 2 units down. I'm going to stretch this by 3. Remember, vertical stretches, your x-intercept doesn't change. So those dots are staying the same. This time, this guy is going up to 6. So that's where it's at now when I stretch. And now I move that down 2. Is that different? Yeah, much different. Okay. Okay. All right, so then we're going to look at the 4. I want you to pay attention. So that was vertical translation, vertical stretch. That was a problem. Now we're looking at horizontal translation, horizontal stretch. So maybe you intuitively think that's not going to work either, because the vertical didn't, maybe the horizontal doesn't. Okay, so y equals f of x is shown. Sketch the image of the function after a horizontal translation of 1 unit right, followed by a horizontal stretch by a factor of 2 about the y-axis. So let's do the first one first. Horizontal translation 1 right. That's there, that's there, that's there. So this is the first one. Okay. Horizontal stretch by a factor of 2. So remember, this is going to stay the same. That y-intercept is going to stay locked in for horizontal, but these are going to move. So this one right here goes from -1 to -2. This goes from 1 to 2, and this goes from 3 to 6. So it's going to look like this. Like that. Okay? So that's what it looks like. We'll do the second one here. Okay. All right, so that's all right. Let's look at the second one here. Second one, we're going to go ahead and stretch it by a factor of 2 to start. So a factor of 2 would move this one from -2 to -4, from 2 to 4. That will stay the same because it's centered, because it's on the y-intercept. Remember, y-intercept won't change. Now we're going to do a horizontal translation 1 unit right. So if I move this over, that's now here, here, and here. So it's going to be... Okay, so that's what it is now. So it is a little bit different. It is close, but not quite, because you can look and see that this right here is at 3. This is at 2. Okay, so they are similar, but they're still different. Okay? So yes, different. Or yes, it matters. That's how you answer. Like the order did matter there. That's how we're answering those questions. Okay, so summary. What did we just figure out? Well, you notice the horizontal stretch and horizontal translation have an order problem. So in general, order does not matter when. So this is when you don't have to worry about order. 2 translations. So up, left, down, right. All those are fine. 2 stretches are combined. Vertical, horizontal. We did that in the notes. A translation and a stretch at right angles to one another are combined. So that just means that they're like moved in the same direction. Reflection stretches are combined. Those are fine. That's just, we know that. That's like a -3. So that's your vertical stretch of 3 flipped. Okay, you can flip, then stretch, or stretch, then flip. That's fine. All right, order does matter. Yeah?
Just in case you just moved in order for everything.
Yeah. Right, like these?
Yeah, basically.
Yes. Right.
Not matter, you can still do it.
Correct. You can still do it the order that you think seems normal, when it doesn't matter because you can do however you want. Yeah. Yep. Okay. The order does matter when a translation stretch in the same direction are combined. Vertical stretch, vertical translation. That's what we're talking about. Okay, those ones. Most reflexive translations are combined. So whenever you kind of have a reflection and a translation, Reflection comes first because reflection's a product, right? You're multiplying. So just like order of operations, you would do that first. So this is kind of the flow chart of the order you want to go. Okay, stretches, reflections, translations. Okay, stretches and reflections because they're products. Translations is last, it's plus or minus. Okay? All right, let's go do some examples of these. All right, let's try this one. Describe a series of transformations required to transform A to graph B. Okay, A to graph B. All right, I think also, why don't you just try the next two? C, we're going to hold off on because it takes a little bit of work. I want to make sure we do it clearly last class because the problem is the answers vary on that one. So last class, people are putting up answers in here, and we were trying to go through it, and it just got a little messy. So I want to try to just get a couple of good ones I can show you in a video, and maybe I'll post that separately. So don't worry about C today. Okay, so describe a series of transformations to get A to B. So let's just talk about it. Did it flip over the y-axis? Yeah, flipped over the y-axis, right? Has to do this flip over the y. So we know it's a flip over y. Okay, so if it flips over y, I'm right here. What do I need to move now? 2 left and 3 up, if you can't see it. Okay? That's the movements. They don't have a function for us, so we don't have to plug that in, but let's just for practice, if we took the original f of x, that means we would go flip over y, so it's going to be f of negative x. See, it's a little bit tricky here, because if I'm going 2 left, that means I have to go minus 2 now, but I'll talk to you about that later. Don't worry about that for right now. And then 3 up. It's because it's opposite, but don't worry about that. They just want you to write the words, so that's an overachiever thing, don't worry. All right, graph A to graph B. So obviously A is what? Smaller. So we're going to have to go ahead and enlarge that thing by doing what? Horizontally stretching. Okay, now it's centered at 0, so you can see that this is twice the size. So we want to go ahead and stretch this by 2. Okay, so go ahead and try these two. That's kind of your hint. We'll kind of get together, and I'll let you guys give me some answers. Maybe I'll just kind of help you guys get A going here. So we know I have a horizontal stretch of 2. And when you do that, the new image is going to look like this because it's going to go 2 this way. Because it's going to double, and it's going to go 2 this way. So that's your new box. And now you want to figure out how to get to B. So then you kind of think, okay, I'm right here. That corner is right here. So how am I going to translate that to that spot? So it's going to be left 4. Down 1, 2, 3, 4, 5, 6, 7. That's what you would do, yeah. You can do both. Yeah, this one it says describe. You guys see describe, it's just kind of using words. Yeah. So now try C. So C, instead of doing horizontal, you probably want to do vertical, so it gets more like C, and then move it from there. So go ahead and see if you can do that one now. A to C, what do we got? We got a stretch again of vertical stretch of 2. And then from there, since you're going to be right here, you want to move it up 1, 2, 3, 4 up, right? Okay, and then 4 up and 6 left. Okay? Perfect. All right, let's finish this out. Then you guys can do quiz corrections and work on this assignment. Okay, so let's go ahead and go. I'll play with this one some more after the notes. All right, describe which transformations are applied to the graph of the following changes made to its equation. Do the order of the transformations performed affect the graph? So we're going to do both ways, like switch them, and then see if it matters. So like, for example, replace x with 3x, y with y plus 4. So if we do x with 3x, so we have the function, we're just doing f of x. So that means we would go, the first thing we'd go y equals f of 3x. Then we do y plus 4 equals f of 3x. And then we'd minus the 4, right? So it would be, I'll come over here. Okay, so that's the first way. That's all. Now I'll flip the order. So we'll do y plus 4, okay, minus the 4, and then put the 3x in. Sorry, let's make this a y. And you can see between these two, no change. So there's no problem with the order there. So order doesn't matter. It also says to describe the transformation. So the transformations, I don't really have room here, so I'll just kind of do it out loud. The transformation of this one is a horizontal stretch of 1/3, good. And then a vertical translation down or up, down 4, right? So we got a horizontal stretch of 1/3, vertical translation down 4. Okay, good. Okay, so let's go ahead and do this one. Okay, so the first one, so it's going to go y equals f of x, and then we're going to go to y equals 2/3 x. Oops, I want to do f of 2/3, sorry. F of 2/3 x. Then we're going to go the negative 3y. Okay. And when I move that negative 3y, that makes it over here as a what? Negative 1/3, good. So it's going to be y equals negative 1/3 f of 2/3 x. In the last step, we're going to plug in the x with an x plus 2. That. Okay, so we'll leave that. That's the first way. This is the end game. Okay, let's just talk about these movements out loud first. And one thing I just want to just kind of spoiler alert. Notice that we're doing 2 x's, right? We talked about earlier that being a problem. Okay, we talked about that earlier being a problem. So let's see if we have a problem again. But what's just the movements, what's going on here? So what's a 2/3 x do? Horizontal stretch of 3/2. Yep. What's a negative 3 do? Reflection over x stretched by 3 vertically. X plus 2 moves it 2 left. 2 left, the opposite for x, yeah. Okay, let's do the other way and see if it's different. So the other way, so this is option 1, this is option 2. F of x. So the first thing we're going to do on this one is we're going to plug in the x plus 2 first this time. So y equals f of x plus 2. Then we're going to do negative 3y equals f of x plus 2. Then we get the negative 1/3 again. And now we're going to plug in 2/3 x for this x. Not negative 2/3, positive 2/3. I don't know why I said that. Okay. Okay. So are they different? They are because look, 2/3 is only on the x here. 2/3 it's the x and the 2 here. It's distributed. So that causes them to be different. So order does matter with the situation, which I already highlighted. Okay? So just going through that, you can see the change. Everybody see the problem? Oops. These two. Just see the little subtle, that bracket. This 2/3 got to distribute. This 2 is not getting hit. Okay, that's the only difference. All right, last one. Stay awake, stay awake. Okay. All right. This here, so we're going to go ahead and move. Okay, we're going to move this parabola around, what they tell us to move. And then we're going to talk about it just down here in terms of what's happening. So it's an x squared plus 1 parabola. So we're going to do the order they tell us. So they're telling us to do this order. So then, like what you're saying, Jake, the order doesn't matter here because they're giving me like almost steps to do. So I have to do it in this order. Horizontal translation, 2 units left. So let's just go ahead and just try to keep this a little bit clean. So we'll do this one in red. So 2 units left just means that's there, that's there, that's there. That's after the first one. Okay, green for the second one. Reflection in the x-axis, so we're going to flip it down, because here's the x-axis. So here, that reflects to here. That was at 5, so I'm at -5. And there. So that's this spot. Okay, and then onward here, we'll go blue. Vertical stretch about the x-axis by a factor of 0.5, so it's being stretched 0.5. So that means that the y values are going to be hit with a 0.5. So it's going to be stretched about the y-axis. So if this is a 1, where's the next spot going to be? So here's a question. Vertical stretches, we never change the what? What doesn't change? X-intercepts. Do we have any? No. So that means that we have all these spots are going to change. Does that make sense? So all this parabola is going to be moved. So that's at -1. Half of that is -1/2. This is at -5. What's half of -5? -2.5. And so this is what this graph looks like. Okay. And lastly, we've got yellow for the last one. Vertical translation 3 units down. So we just take these. 1, 2, 3. 1, 2, 3. 1, 2, 3. So this is our final product there after all those movements. Okay. And then we're just going to fill out this grid of like what you're replacing. So when you do horizontal translation 2 units left, what are you putting in? Okay. All right. Let's finish out. Come on, come on, come on, come on. Here we go. So if I'm doing 2 units left horizontal translation, that means we're going x2, x plus 2, right? And so that means from the x squared plus 1, we are changing it to x plus 2 squared. A reflection on the x-axis. That means my y is going to a -y, or we're flipping the function. So that means negative x plus 2 squared minus 1. Remember, both things that hit the negative. Vertical stretch about the x-axis by a factor of 0.5 or 1/2. That means that y goes to 2y, which means we divide the 2, right? I don't really like writing that much. That's how the book explains it. But just knowing that 2, we're going to divide that off, so it's going to be a 1/2 over here. That's all that means. So like that. And lastly, vertical translation 3 units down. Y plus 3, because we're going to minus it over. And this is what we got. No. Oh, wait, yes, yes, yes. Yep, 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 yep. Yep. Good job. -1/2, so that would be the, it would just be the 1/2 because we already hit the negative. So the 1/2 would make that just 1/2, yeah. That's why we're at 1/2 there, good. And then we did down 3, so it's -3 to 1/2, which is -7/2, -3/2, yep, thanks. Good, good. Got off my notes, I was trying to be done. All right, good deal. So that yellow line up there that we had is this equation. That yellow line is this equation. All right, cool.